Moving along to 11a, we've been given the graph of y is equal to 3 times 2 to the x. Now that means my horizontal asymptote is at y is equal to 0. And what's happened is I've got my classic a to the x type, and it's been multiplied or dilated by a factor of 3 times. So I can quickly find my y-intercept. Even at this stage, you've got to write down that factor. Or 0, 3. Second point, x is 1, y is equal to 6, so I've got 1, 6. If you want to check that on your calculator, you can see that we've definitely got a graph for horizontal asymptote x is 0, the 0, 3, never touching the x-axis. Sketching that up. Get a graph just as we saw on our calculator. Looking now at 11b, what we've got the classic a to the x graph, horizontal asymptote at x is equal to 0. There will be a very slight dilation. I found my first point, x is 0, y is 1. The next point, 2 to the 3, 8, which gives me 4, 8. And that will then give me enough fuel to be able to sketch my graph. And as before, x is an element of the real, and for my range, 0 to positive infinity. Looking more slightly quickly at 11c, you can see how we've got the a to the x, a to the negative x is reflected in the y, and in turn, this is reflected in the x, the opposite of a to the minus x. So reflected around the x and y, it's going to be dilated 3 times. Finding the y-intercept gives me negative 3. A second point, I've chosen a third, gives me 1, negative 6, and my graph as follows, or 1/3, negative 6 in this instance. Negative 1/3, negative 6. You can see there the domain is an element of the real, and we go from negative infinity to positive infinity. And as you can see there, looking at the graph on the graphics calculator, you've got that kind of thing happening there. And that should be, negative 1/3, negative 8 in that instance. I've done the last one a bit more quickly. Look, it's going to be reflected around the y-axis, horizontal asymptote at the origin, at y is equal to 0. It's dilated 1.5 times. So my y-intercept, second point, will give me a graph of that order.